Hey guys, welcome to my podcast that the sub is showing you as a class. My idea for this is to kind of explain a little bit of our thought process on yesterday's activity and then lead you through some steps of how we can make this rotational design shape relatively simple. Um, Yesterday, the question I gave you was we want to make this shape out of stained glass material. We'll be using paper, not actual stained glass, even though stained glass would be a lot cooler. I have stained glass paper that Miss Dolan let me have, so we'll see how cool the shape will look based off that. What I asked you guys to do though is to kind of get a feel for the shape. So yesterday in GeoGebra, you guys just tried to make this on your own. Fourth period, I saw a lot of you guys making the correct shape, and it was really cool to see. Sixth period, there's only a couple of you. But what I saw mostly were students who tried to take this shape, and I gave you this as a handout, right, which gave you the framework, showed you also in this picture over here segments that are congruent and whatnot. And we're going to use these facts here to help us build our shape and talk about some geometric things here. Um, so if you guys didn't know properties and you just kind of looked at this and you started clicking all these points, making points happen, what you end up getting are a couple different looks. One of them is like this, and this is a student that I asked to borrow their work from, and you can see that it looks a lot like, our design here, but there's obviously some things going wrong in it. The reason that I asked for congruency, when I made this design, I made segments that are congruent, and that creates this nice symmetric, just, I guess, what's the word I'm looking for? Uniform shape, I guess, when we use congruent segments. Whereas this student didn't take, like, for instance, this interior pentagon right here. That's what we're going to start with when we make this. These sides are all congruent, right? That's what it means for all these little congruent segments there. So um, when you look at this person's design, notice this interior pentagon, right? Inside here doesn't have congruence. And we got all sorts of crazy stuff going on here. But sorry, that's how this student saw the design, and this is what they made. And I hope by seeing some examples of some that didn't work out that great, um, we can appreciate the idea of symmetry and congruence and really properties that make figures either isosceles, equilateral, or whatnot. Okay, so if we were to rotate this one, it wouldn't be, the greatest thing in relationship to a nice symmetric, what we call rotationally symmetric design here. But now, if you follow the steps and whatnot, you can get a nice shape that looks like this. This is another student that I asked to borrow. So these two students, you can kind of see who was just trying to make things happen and who was really trying to use the properties of what's going on here. So this is a nice shape as well, right? It looks a lot like the shape that I gave you. Okay. Now, one thing here with these, with a shape like this, these purple points that are on GeoGebra, that means I can move them around, right? So notice how she designed this design here has to do with some rays and some points that depend on other points. And notice as we move one thing around, other things move around. And this is what we call a construction. What I want to do is I want to make everything fixed in this design and really only be able to move two things. So from the actual design, oops, which looks like, oops, my bad, this design here. Basically, in my design, there's only two blue points, which means all I want to do is base off of one segment, everything else stays in proportion. You see what I mean? Every other point other than these two right here are these dark gray points here, which means they're stuck, right? This is a true construction based off of just one side length. We get this nice geometric design. Um, so this is how I'm going to lead you through the discussion then of how you can actually design this shape. And really all that we need to move is one segment. And that's what it means to be a true geometric construction, because one segment length defines all these other segment lengths. Okay? Now, if we look at the picture that I gave you with the congruent symbols, we're going to start with this interior pentagon here, right? We're going to make this shape first and make it so that all its sides are congruent. We're going to define what regular means in geometry. And then notice these triangles off of the side here, which I'll make a different color, um, like these ones. They have the same congruent segments, right? So these are, because all these are the same, these are equilateral triangles, so we'll make those. But if we can identify shape, then we can identify how to make these designs much easier. And then based off that, it looks like all we have to do is connect these endpoints of our equilateral triangles, find the midpoints, and make little segments, and make a star in between. Okay, so let me show you how we do that with GeoGebra. So if you're going to follow along with me, let's get a blank screen, view my algebra window. I might need it. And first things first, looking at our design, let's create this interior pentagon. I'm going to use a tool to show you this tool here, and then we'll talk about this later. If we go to our polygon tool and you hit the drop arrow, you can grab your regular polygon. What regular means in geometry is that it creates a shape where all the sides and all the angles are the same, which is what this interior pentagon really is. And even the exterior is regular. All these sides are the same length. So let's build this interior one. So what I'm going to do first of all, if you hover over any tool, it'll tell you how to use it. Select 2 points and enter number of vertices. So what selecting 2 points does is it creates a side length. That'll be this long. It asks me how many vertices I want to make, how many points on our polygon. And since we're making a pentagon, it's got 5 points. So we're going to type 5 in vertices here. And when we click OK, it just creates a pentagon that's regular, meaning all the sides are the same, based off of those 2 points that we put on there, right? And these are the only 2 things in our design that we're going to be able to move, are these 2 points that create a side length. But regular means now this pentagon has all the sides that are the same length as the one that we defined. Okay, so this is like our interior shape right here, this interior pentagon. Okay, um, now that we have those, let's make that interior star real quick. So what we can do is grab our segment tool between 2 points, and I can just make all my diagonals, right, in a pentagon. If we connect all our points with diagonals, we make the star shape. So that's where we get our star in the interior here. Now let's build these equilateral triangles, right? If these triangles here have side lengths that are the same side as our pentagon, then I'm going to grab my regular polygon tool again, and I'm going to make, maybe off the side AE that I have here, I'm going to make a equilateral triangle that has this length. So with my regular polygon tool, I'm going to click on point A, then point E, which defines the side length. I'm going to tell our GeoGebra that we want to make a triangle, so 3 vertices, and click OK. And notice I have a nice triangle that's coming off of my pentagon here. If, for instance, when you make this and you click the wrong direction, like we had to go A then E, and it creates this point. But if we do this, like for instance, I'm going to make a equilateral triangle off this side, AB. If I click on A and then I click on B and I tell it to do 3 vertices and click OK, and it makes a triangle inside, then we have to just click the order of our points differently. So I'm just going to undo that regular polygon, and I'm going to click on B then A, go 3 points, and notice now I get my triangle, right? So now I'm just going to go around my pentagon, and I'm going to use my regular polygon tool to make equilateral triangles that have the same side length as the pentagon. So if you guys need to, ask the sub to pause this video so that you guys can get caught up. If you need to, just say, whoa, whoa, pause that please, or rewind that um, if you're not following along. But hopefully you are. Okay, so right now you notice everything is with the polygon tool and our regular polygons, everything is this ugly kind of brownish red color. Later we'll go back and we'll change the polygons and stuff. Each of these that we made, this pentagon and each of these triangles are their own polygon. Okay, so you could change the color in them right now if you want. But these ones inside of here, we want to change color, right? Because we want something like this. So we're just going to need to come in later and find these intersection points, create polygons, and then just change the color that way. Okay, so to finish off our design here, let's grab our segment tool and let's connect our endpoints of our star, which just creates a pentagon. And now we need to find the midpoint, right? Because we want to create these little green and red triangles in here. So if we grab our midpoint tool to find the midpoints of these segments, which is in our new toolbox, or new point toolbox, grab the midpoint or center tool. And all we have to do is just go around and click on these segments, and it will automatically find the midpoint for us. And then notice now all we need to do is, oops, sometimes if you guys had that happen to you. Okay, now all we have to do is connect our midpoints with these tips of our pentagon. And notice we have our shape, right? So there's our shape, minus the color. Looks a lot cooler when we put color to it. So I want you guys to make sure that you have the shape. Notice, did it again. The only two points right now that are blue that we can move around, all the other ones are that dark color, which means we can't move around, makes them a true construction, are these A and B. So we can move these points around, and notice we have a nice symmetric shape here that we didn't have to do any guesswork and make it look like some of these, you know, no offense to whoever made this one, but it doesn't look as nice as this one that we made here. Okay. Now the cool thing about this is just a pentagon, and we can actually extend this whole process and make it even bigger. We can do equilateral triangles based off of like this side. Let me grab my regular polygon tool. So we could do something like this, right? And extend the shape, which is kind of neat about these designs. I don't expect you guys to do this, but just showing you how you can. So if you're actually done and you're kind of bored, why don't you extend the shape and see what it looks like? So, anyways, color your original shape, this interior one here. Make all the pieces a different color. And then tomorrow when I'm back in class, we will do some proof stuff about all these congruent little triangles in here. And then we'll make our own little stained glass project. So hope that video made sense, guys. Take the rest of the class period to design your star, make it look nice, and make sure you're caught up. If you need to, you can show that video again and get the parts you need to make your shape. But work together as a class, please, and everybody have your design done for tomorrow. Thanks, guys. Good luck.